In this video, I'm just going to run through the energy mark task 1. So you can see we start with question 1. So the bar chart shows different energy sources used to generate the UK's electricity in 2007. So you can see you've got renewables here, then nuclear, fossil fuels. It then says for part A, the wind is a renewable energy source. Name one more renewable energy source used to generate electricity. So here's quite a few that you could use. You could go from waves, the tide, you could have hydroelectric, which is caused by falling water. You could have solar power panels or solar power or solar cells. And you could also have geothermal and biofuels as well are considered to be renewable. So any of these would get you a mark for this question. So you could have any one from the following: waves, tidal, hydroelectric, solar, geothermal or biofuels. So it's 1 mark for any of those. So you're going to move on to part B. Part B says the graph shows how the demand for electricity in the UK varied over 1 day in the winter. It then asks us to, for part 1, describe how the demand for electricity varied between 4 AM and 10 AM. So you just mark these on the graph. You can see there's 10 AM, there's 4 AM. We want to describe the changes involved here. So I'm just going to highlight this graph. We've got 2 different bits, I believe. So that part there where it's an increase between 4 and I think that comes into about 8 AM. And then we can see afterwards it's a steady line from 8 AM till around 10 AM. Okay, so the 2 marking points for this is that the idea that the demand of electricity increases from 4 AM till 8 AM. That's because people are beginning to wake up and beginning to use electricity to help them get ready for work on one thing or another, and also workplaces are beginning to open as well. The demand then remains constant from 8 AM till 10 AM because people are already using that electricity. We've got a constant need for it from that point because people are usually awake at that time. So there, it's a mark for each of those points there. Part 2 of the question says, which type of power station has the fastest startup time? It wants you to draw a ring around your answer. So startup time is basically how quick it is for the power stations to start. Coal and nuclear have a very long startup time. Oil somewhere in the middle, but natural gas is definitely the quickest. So natural gas is used to meet surges in demand for electricity. Okay, question 2 is what we're moving on to now. It says the pie chart shows the relative proportions of electricity generated in Japan from different energy sources in 1975 and 2005. It wants to describe the main differences in energy sources used in 2005 when compared to 1975. Okay, so we've got the grids here. It might just be useful to try and annotate them a bit. So we've got the use of oil. You can see in 1975, this is where oil was, lots of oil, compared to 2005, so oil significantly decreased. Okay, the use of gas is this one here. Okay, you can see that that has significantly increased in use from 1975 until 2005. We've then got coal being the large black part. You can see there that this, I'll take that with a black pen. So a small amount of coal was used in 1975, where a much larger part is now used in 2005. And then we've got the idea of hydro and nuclear. So we'll do nuclear in red. As you can see, nuclear is relatively small, but now it's huge, isn't it? We used a lot more nuclear in 2005. And the last one that we're going to look at is the use here of hydroelectricity. So hydroelectricity was quite high in 1975, but that's reduced to 2005. You could talk through any of those in order to get your mark here. So actually to talk about the main differences, the first thing you need to do in order to get the mark is the main difference is that we've got a decrease in oil. Oil was being used for a huge amount in the green bit, whereas now it's used for a much smaller part. So decrease in oil on its own would not get you a mark, but that's the first bit you need to include. We need 1 more point after this in order to be able to get the full marks of the question. Okay, and then for the second mark, you need to say there's been an increase, and you need to talk about any one of these 3. So there's an increase in coal, increase in nuclear, or an increase in gas. They're the main changes, really, that we need to talk about. Now, your answer must include there's been a decrease in the use of oil, so you must have oil in, and it must have an increase in one of the others. So to have those marks, you must have decrease in oil and then an increase in either coal, nuclear or gas. And that will get you the mark for that question. So moving on to part B, it says in the UK, nuclear fuels are used to generate about 21% of the total electricity supply. What is the name of the process by which nuclear fuel produces heat? That process is called nuclear fission. So again, that process is called nuclear fission. The only part of the bit you need is the word fission. So you wrote fission there, you get the mark, but it's nuclear fission is the process that nuclear fuels are used to produce heat. It then says in part 2 of question B, some people have suggested that more nuclear power stations should be built in the UK. Give 2 reasons to support this. So I've included my 2 reasons that I think are the most important in terms of why we might want to use nuclear power stations. That is, it's a very reliable source of energy, so it produces lots of energy. It's always producing electricity when you need it, and it's very reliable. That's the main advantage to nuclear, in my opinion. Okay, the other advantage to nuclear is it produces no atmospheric pollution. So it doesn't produce greenhouse gases, it doesn't produce carbon dioxide, it doesn't contribute to global warming. I think those are personally my 2 reasons why I think nuclear power stations should be used. You can also have other reasons, such as that it produces lots of energy for a small amount of mass. The idea that fossil fuels will continue to be able to use them for longer or make fossil fuels last longer. It's also helpful for the UK because we wouldn't need to buy electricity or methods of generating electricity from other countries. So the moment we rely on France, for example, to get some of our electricity generation, which we would no longer have to do. So any of those answers that I just discussed there would be acceptable to get marks for this question. Part 3 of the question says nuclear power stations create dangerous waste. Why is the waste from nuclear power stations dangerous? And with that, you just need to mention that it's radioactive. So nuclear waste is radioactive, which means it emits ionizing radiation. So you've got the final marking point here. So the idea that nuclear waste is radioactive by itself will get you the mark, or by saying nuclear waste emits ionizing radiation would also get you the mark. So you can have either part of that question there. But for completeness, nuclear waste is radioactive, which means it emits ionizing radiation. Okay, so we'll move on to the final question now. So the final question says that Iceland is a country that generates nearly all of its electricity from renewable sources. In 2013, about 80% of Iceland's electricity was generated using hydroelectric power stations, or HEP. Describe how electricity generated in a hydroelectric power station include the useful energy transfers to take place. Okay, so we want to describe how that electricity is generated, but we also want to talk about this idea that they've got across there in terms of include useful energy transfers that take place. Okay, so you can see over here, I've just done a quick sketch to remind ourselves of what hydroelectric power stations is and how they work. So we have water in a top dam, high dam. That water will then fall into a lower dam. And as it falls, it will turn a turbine, and that will drive a generator, and the generator will produce electricity. So that's the process we want to talk through. So that's how electricity is produced. We also want to mention the useful energy transfers. So as the water falls, what energy we're using here? Well, we're taking the gravitational potential energy at the top and turning that into kinetic energy as it falls down. That's the first one. So as the water falls down, that's what we get in terms of energy transfers. In terms of what happens next, well, the kinetic energy is it turns a turbine. The turbine drives a generator. So that kinetic energy is then going to be turned into electrical energy, which is used to power our homes. Okay, so here I'll put the answer on so you can see it and work through it together. So water is released from a high reservoir to a lower reservoir. Okay, that's the first mark. The energy transfer is taking place at gravitational potential energy to kinetic energy in that case, as we go from a high area to a lower area. As the water falls, it turns a turbine which drives a generator that generates electricity. And the energy transfers that take place here are kinetic energy going to electrical energy. And that will get you the 4 marks for this question. Thank you for listening, and goodbye.